And welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we'll take a little detour and talk about image augmentation. And the reason is because in the next video, where we'll look at the perceptron, we'll use this data set to fit the model and classify the images into two sets. So, what is image data augmentation and why do we need it? So here, if you look at this image, I've drawn it thinking that that image in in yellow is a sun image. Now, what I've done in this data set, I'll put a link in the description of this video so you can download this data set. So there are 100 images of clouds that I've hand drawn and 100 images of sun, which is shown here, that I've hand drawn. And because 100 images may not be sufficient, we need more data. And so to create let's say 1,000 images, one of the method to do that is image augmentation. What image augmentation is we take this original image and then either rotate it, shear it, blur it, add noise to it, do various types of transformations. It still represents the same image, but now it has a little artifacts added to it, and that's what is called as image augmentation. And you ask, why do that? So one of the advantages of doing that is uh, you have more data, and because you have more data, maybe the model that you are trying to train, it'll fit better and it'll give you more accuracy because you have more data. And here on this slide, I have one example where the very first image on the top left, this one, that's the original image, and then these subsequent images are augmented images which can be used to train a model. uh, they all represent the same image, but in different forms. So here these are rotated image, here is the shear image. So shear as in stretched image, plus it's a wrapped image. So half of the image is on this side, other half is on the other side. This is just wrapped. This is image with noise. So I've added some noise, and that's why the image is pixelated. And then here we have a blurry image, and then finally this is a flipped image. So let's get into Jupyter Notebook and see how we can write a code to augment an imaging dataset. Here in the Jupyter Notebook, I've imported these libraries, and this is the version that I'm using. Now, the way we are going to write the code is by first creating a function that would have all the lines of code that would perform the transformation, and as we go through the function, we'll try and test it each time we create each time we add a code for transformation. So for this, we'll call this function as augment underscore image, and this takes in a path to a particular file to read. And let's say the file that comes in is read by io.imread, and here we specify file, and we'll read it as a grayscale image. So we said as underscore gray is equal to true, and to just check that, we'll return this img and test it to see if that works as we want it to be. And to do that, I've downloaded the dataset on my computer, so it will have a different path than the place where you may have saved the downloaded files. So the path that I have the files located at are is this users underscore erv desktop data, and then sun underscore 2. That's the image I'm going to use. And if you say augment underscore image and then specify the path to that, it's going to return this image. So I'll call that image as x, and then use that to perform to get what output we are looking for. So let's first look at the shape. So x dot shape, and then plot it. So for plotting, I'll use a plt.im show, and this would be x.reshape because the image would be Well, in this case, there's no need to reshape it because the image would be of the shape that we are looking for, and that should work now. So that's a 64 by 64 image, and that's the original image that we have. Now, as we build this function, we'll see different transformations happening to the image. Now, to give you an idea of what the imaging dataset is that it has two types of images. One, there are 100 images that I've hand drawn for clouds, and there are 100 images hand drawn with sun. So we are going to augment each of those images and increase the data set size from 200 plus 200 to more than 200. And the idea behind clouds is that we label that as 1 because clouds bring rain, and then when it's sun there is no rain, so we label that as 0. I'm going to specify that here, class label, and here 1 is equal to cloud because clouds will bring rain, and then 0 is equal to sun because there's no rain when there is sun out. So with that, the first step that we'll do is use os.path.base name to pull the name from the path. So this is the path. So if you type, let me type that here. So here, if you type os.path.base name and specify the path, that's the name you get. So what you want to do then is put a split on that. So if you split this with an underscore, that's what you get. And then if you look for just the 0 part, that's the word you get. So that's exactly what we are looking at. We are looking for that string sun, and what I'll do is put that in here, and instead of path we are using file, so I'll just replace that with file. Now if this particular string that's output here, if we say is that equal to cloud, if it is, it's not in this case, as we know. And here if this is equal to cloud, then we'll set the label yi is equal to 1, else we'll set the label as yi is equal to 0, and that takes care of the class labels for us. Now the next thing that we'll do here is the first transformation is rotate. So the image I1 is equal to rotate, and rotate, and this would be img, and the angle, let's start with 30, and I'm going to reshape this image because we are going to eventually put it in a matrix or array, and so that's the image we have. And what I'll do now is run the function and we'll test if that works. And to do that, I'll delete this part now. This is the image that we had created earlier, which was our original image, and now we'll keep that image down there and we'll add the augmented images here. So the first one, now we'll run the same function again, and this time here, as you can see, the shape is 1 by 4096. So 4096 is simply 64 by 64. So if you multiply 64 by 64, those are the total number of pixels in that image. So that's no good for plotting it, and therefore we need to reshape it. So I'll go and reshape this to shape 64 by 64, and now when we plot it, we get the rotated image. So as you can see, this is the original image, that's the rotated image. And so that is for angle 30. We have we'll try a total of 10 angles. So 1 2 3 4 5 6 7 8 9, and that's 10. And so the angles I had in mind were 30, 45, 60, 90, then we have 120, 150. I'm increasing, going in an increasing order of 30 degrees. 180, then we have 210, then we have 240, and then finally the last image for rotated is 270. and I'll go ahead and change these variable names as well, so each of them are stored in a different variable, and we'll put all of them in a list at the end of this video. So let's run this again, and that's the image that is rotated by 2. Let's put a 10 there. So that's the image rotated by 270. That's the original image there. So now we have successfully written the code for rotation. Now let's work on shear. For shear, we'll use affine transformation. So AF and underscore TRANS transformation. So AFFINE transform, and for this we'll put a shear of minus 0.75. You can try playing around with different values and see what type of transformations you get. And here I11 would be the image that would be created, warp, and here I have IMG, and then F underscore transformation order is equal to 2, preserve range, preserve underscore range is equal to true, and we have mode is equal to wrap. So if this, let me go ahead and reshape this as well. So I11 is equal to I11 dot reshape 1 minus 1, and let's return this. So the reason, one thing we can always do is check if the code that we are writing is passing the correct arguments to this. So as you can see here, we are passing the image, which is the first one, and then we are setting the order to 2, so the description will be down here, and I've used preserve range is equal to 2, and mode is equal to wrap. So if we go down here, uh, mode is equal to wrap, that's what we are using. And when we run this, in before the video when I ran this, I got some warnings. So let's see what we have this time. So run this one, and the returned image now would be I11, and we get this image that is sheared and wrapped. And here, as you can see in the warning, it says we recommend use bilinear or bicubic interpolation. So we have bilinear, which is default, that's what was used. So bicubic, so if we set the order is equal to true, maybe that would change. Order is equal to maybe 3. So if we change that to 3, run this again, and this time we do not get that particular order. So that this help menu is really helpful. So that's the shear part that we have now created. Moving on top of this, we'll add wrap, and for wrap again, I'm going to create a variable transfer is equal to affine transform, and this translation is equal to minus img dot shape. So the shape will put half of the image on one side and the other half on other side. Therefore we have image shape 0 by 2, and we'll save that in variable I12, and again warp is into parenthesis img transform, mode is equal to wrap, and we'll also reshape this. So I12 dot reshape 1 minus 1, and we can get the output again here as 12. So let me close this and maybe just comment this out, because we don't need that help menu again. So as you can see, this is a image that have split into 2 edges, and that helps the model learn uh, different parameters for that image. Next we have noise, so we'll add some noise to the image. I'll create the image 13, and this is random underscore noise, and image var is equal to 0.1. That's just how much noise you want to add to the image. And then again we'll reshape this, so I13 is equal to I13 dot reshape 1 comma minus 1. And let's go ahead and run this and see if we get a pixelated image. So yes, we do get a pixelated image, and that's good. Moving on, now let's add blur to the image. So blur, for blur, create image I14, and this is nd image or uniform underscore filter, and img size is equal to 4. So the size of blur that you want the image to have, I14 is equal to I14 dot reshape 1 comma minus 1. And if we return this image and run this, we get a blurred image. As you can see, the edges are blurred out and we cannot see the well defined outline of the sun from that image. After blur, the final one that we have here is flip. So I15 is equal to np dot flip upside down image, and we'll also do the reshaping of this. So reshape, this would be 1 comma minus 1, and we'll go ahead and run this. And as we should see, this is the flipped image of this original image as we see above. So that completes the transformations. And finally we will put all these images, augmented image list, into a list, and I'll call that list as a xi. So within xi we now have I1, I2, I3, I3, I4, I5, 6, 7, 8, 9, 10, I10, I11, I12, I13, 14, and we have 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So those are all the images. And before we complete this function, we need to take care of the output. So the output label would be the same for all these augmented images because they are originating from the same image. Therefore I'm just expanding that uh, that list with one value that we had created above to match the length of this augmented image list that we created. And this function will now return not only the augmented images but also the labels associated with it. So after this, we are now in a pretty good shape to plot all these combinations of images that we should get in a subplot figure. So for that, let's create a sub figure with subplots. Plt dot figure fig size is equal to, this would be 15 by 4, and we have rows and columns is equal to 2 comma 8, and this image x is equal to, this is the original image, so I am read path, and this as underscore gray is equal to true. We are reading it as grayscale. Plt dot subplot r comma c comma 1, and so that would be the first image in the top left. Plt dot imshow imgx dot reshape 64 by 64. Probably we don't need to reshape this. It should already be in that shape. So why don't we run this imgx uh, as okay. So the image is good. Next, we'll first run uh, the image sun underscore 2 dot png through the function to create all the augmented images. So we'll store them in xx and yy is equal to augment underscore image path. And once we have that, now we can go ahead and plot them. So for I in range, length xx, and here we can specify plt dot subplot r comma c comma I plus 2, and plt dot im show xx xxi, and here dot reshape. Because we flatten the images in the function, we need to reshape them here, and we'll add plt dot height underscore layouts so that there is even spacing in the subplots that are created, and then finally we have plt dot show. So this should create an image figure of subplots that we have seen previously on one of the slides, with 2 columns, 2 rows and 8 columns, as you can see. So we have this original image on the top left, and then we have this series of rotated images, and finally we have these wrap and shear, and then noise image, blurred image, and flipped image. I hope in this video you got an intuition about what is image augmentation, why is it needed, and how we can implement image augmentation on a dataset using Python. You could also create different types of image sets, and you could draw 10-15 images and then square images, and then run this type of augmentation function, or you could add some different other types of augmentations to the image and see how you get the transformed images. And in the next video we'll see how you can use this augmented data set to perform classification task using perceptron. Until then, please like, share, and subscribe. Thank you.